Now, using what we know about series and sequences and convergence and divergence, we will begin to look at Taylor polynomials. Taylor polynomials are polynomials that can be used to model complex functions in order to simplify them. The equation for a Taylor polynomial, if you have f of x, the Taylor polynomial is t sub f of x equals the sum from k equals 0 to infinity of the kth derivative of f centered at a over k factorial times x minus, there's a again, your center, to the k power. Now that looks like a lot initially, but as we begin to break it down and write some out of our own, it gets simpler. So this Taylor polynomial, if you expanded it, would be f of a, because 0 factorial is going to be 1, anything with 0 is going to be 1, then f prime of a over 1 factorial is going to be 1 times x minus a plus f double prime of a over 2 factorial, which really is going to be 2 times x minus a squared, and this would keep going until you reach the f n derivative of a over n factorial times x minus a to the n. Now as we do some examples, I'll leave this up there for future reference. So if we want to find the Taylor polynomial for f of x equals 1 over 1 minus x, we'd begin by writing out the first few derivatives of that, which is f of x equals 1 minus x to the negative 1, f prime of x equals 1 minus x to the negative 2, f double prime of x equals 1 minus x to the negative 3, 2, triple prime of x equals 6 times 1 minus x to the negative 4. The nth derivative of this would be n factorial times 1 minus x to the negative n plus 1. Now if we begin to write this out, centered to 0, we would have f of 0, which is 1, over 0 factorial, which is 1, times x minus 0 to the 0, which is 1. So that's 1 plus f prime of 1 is 1. So 1 over 1 factorial times x minus 0, 0 to the 1, plus f double prime of 0 is 2. So 2 over 2 factorial is then x to the 2. Come down the line and have f triple prime of 0 is 6 factorial of x to the 3rd plus x quadruple prime is 24 over 4 factorial times x to the 4th. Now, all of these cancel out, so really the entire series would just be 1 plus x squared plus x cubed plus x to the fourth, so on to x to the n. Now this can be modeled by the expression k equals 0 to infinity of x to the k. Because this will equal 1 plus x squared plus x cubed plus x to the fourth plus x to the infinity, essentially, but we can't write that. Now you see if you can write out the fourth order Taylor polynomial being the to the fourth degree for this function. As usual, pause it, see if you can do it yourself. After you unpause it and a few seconds pass, the correct Taylor polynomial will display. For f of x equals e to the x centered at x equals 0.